Hi everyone, and welcome to another video where I introduce some of the stuff from the Apollo tutorial. Now, this video will be like part 3.5, just because when coming up with the parts, I totally forgot that it would make very much sense to make a video about how you put all the stuff together that we created in videos 1 through 3. So that's basically what this is going to be about. We are going to just see again and review the different parts of the input that Apollo needs to execute an application, and then we will run this Caesar Cipher application that we created in the video so far. Now, about the input. So just to review, we basically have three files which we require to run an application. One is the workflow file, and the workflow, what it specifies is how your application looks like, what functions you have in there and how they are connected. So they are data and control flow. And this is what we created in video 1 using the editor. Now the next thing we need is the type mappings file, and the type mappings are the connections between the functions in the workflow and the actual resources where they can be executed, such as the AWS serverless functions we created in video 2, or like the Docker images we created in video 3. So these files you also should have at this point. And finally, what you need is the input data for the concrete orchestration of the application. In our case, since we're doing the Caesar cipher thing, it basically means we need some input string and some offset, and you need to provide this via a file. That's super simple. That's what we gonna do in this video. Now, for the purpose of the video, in the tutorial repository, you will find a Java project which is set up so that you can directly put in your files created in the previous video, and then it should run. So your directory, when you check out the appropriate repository, will look something like that. So if you look at it, this is just this Java file, this Java project, which looks like that. And we will treat it in a very similar way that we treated the demo repository in the demo video. So we first need to build it. We're going to do it with Gradle wrapper build and Eclipse. This will take a little bit longer for you than it took for me, because again, I have all the dependencies already here. Then we can go to Eclipse and just import this project. So we go to import, we want something existing, we want to browse, and we choose part 3 and the Caesar folder there, and it finds the Caesar repository. We go with finish, the Caesar project, I mean. Okay, and that is it. And now here we will have two launch files. One is the demo launch. That's exactly the same one we used in the demonstration of Apollo to just see how things work. Let's just have a look what it did again. Because now at this point we actually, since we have a better insight in what Apollo needs and what it does, we can review the different components of this demo, which you will find in this demo input folder, and we can just have a look and see what they do. Okay, so we're here. Again, if we run it, then you just see we have an application on the left side. On the right side, we have just the local machine, and if you run it, it just runs through. If you look at the configuration, you see that we have the specification input module, which specifies the specification itself, so our enactment problem. We have the path to the FCL, that's the workflow. We have the path to the mappings. This is these Stinger atomic things. And the other relevant thing is this input reader file. So this is the input Stinger atomic. So if we look at these files, here, for example, the workflow, you see, what is this? This has some data ins, then the body consists of a single function, and then we have some data out. So this is the as simple as it gets for a workflow. This is what we saw in the demo. Then the type mappings says, okay, we have one function type, that's addition, and the type of the resource is demo. that's this type of these functions which we provide hard-coded in Apollo, just so that you can run something without having any deployment and any configuration or anything like that. And finally, we have our input, which just is a JSON file containing all the inputs needed by the workflow. Okay, so let's now have a look at how we actually will run this Caesar Cypher application. So for that, we have this Caesar input. This is the Caesar workflow, which we created in the first video. We have the type mappings for AWS, which we created in the second video, and the type mappings for Docker created in the third one. So you see they are pretty similar. They both map these function types, but the AWS maps them on serverless resources with a link, while the Docker one maps them on local resources with a Docker image. And we actually have a third file in here which combines them. So with this configuration, Apollo would know that you have two different ways of implementing these functions, one locally and one on a serverless resource. Now, we do provide an input for this experiment, but just, in order to, for completeness sake, we will just create this input file quickly ourselves. So it's going to be in our folder, and it's going to be called Caesar input, and it has to be a JSON file. So that's what we have here. And to know what we need, we're just going to have a look at the workflow, and we see the data in of the workflow is one thing which is called original and one thing which is called offset. So that's what we're going to do. We're going to say we have one thing which is original, and we can say that it will be Apollo for now. And we have another thing which is called offset, and that's going to be 2. And that's pretty much it. With that, we have our input file. And now, although we do provide a launch file for Caesar, for the Caesar Cypher, which will directly load the correct configuration and everything, we will just have a look how you would do that starting from the demo. So what we would need to say is we would need to say, okay, we have a different input now. So let's, instead of taking this single atomic input, take the Caesar input we just defined. And then we also need a different workflow, which will be in the Caesar input, the Caesar YAML. And let's, for starters, say that we want to execute that with the type mappings AWS. Okay, now we're good to go. We hit run. So what you see here is our application looks more complex. We have our split, shift, and assemble function. And then we have the resources. You have the local resource and the 3 serverless resources. If you click at the individual functions, you see where they can be executed. So this is this serverless resource, this is this one, and this is this one. Now what you also see is that we have only one instance of shift, and that is because Apollo at this stage doesn't yet know how big the word's going to be that we give it. And for that reason, it has just one of these functions in the graph. But when we execute it, you see that it runs, and then it creates the appropriate number of these functions, which are then executed in parallel. And as soon as we are done, it will assemble them and provide us the result, which is the CRQ and then a Q string. Okay, so that was the whole thing with the AWS functions. For completeness sake, we will also see how it looks if we do it with Docker. Now we change the input, both the string and the offset. So now we should get back to Apollo. So what we do now is we choose a different type mappings file. We choose a type mappings file Docker. And we go OK. Now, one thing that I want to show here is that right now I don't have any Docker images on my system. And this will be the same for you if you, at the end of the last video, pruned your system to free the space. And now one thing to be aware of when you go with the Docker type mappings is that you need one additional module, and this module is in resources, and it's called containers, and there you choose that you want to go with the Docker API, and you choose the operating system. So if I was on Windows instead of Linux, I would have to choose Windows here. But then the second thing is when you run, then the first time you do that, that would take quite a while because what will happen now is Apollo sees that in the type mapping file you provided, it has some options of executing functions using Docker images, and then it checks that you don't have these Docker images installed locally, and it will download them. And this download just takes a while. So the first time you do it, just be aware of it. It will take a while, just exactly at this position. But then when you're there, you can just continue the execution. So at this point, I will jump to the point when at my computer the download will be finished, and we then go from there. All right. Okay, so at this point it's finished. We can actually go over there and check again. And now we see that we do have three images, and those are exactly the three images defined in our type mappings file. And also, if you check the visualization, you now see that you have only one resource, and that's your local resource, and all of our three functions are mapped onto that. And the other thing is that you will see is that if you execute it, then it will go pretty fast compared to the serverless function because you do everything locally. Okay, if we now see, you basically see that the coding string was in fact Apollo, so it managed to decode it back, which makes sense. And then one last thing that I want to show is if we go, for example, with hello world here and whatever, let's go like offset 5. One thing which you can also do is you can say that we will use the file where we define both mapping options, and then as soon as you have multiple options, the question is, of course, how do you schedule? How do you choose which to take? And we will be using a random scheduler here. Now, if you run it, one thing which you will notice is the second time around, it will be much faster because you already will have the images available locally. So here we are. And now if we look at this, you see we again have more resources. And in this case, we have two options for split. We have two options for shift, and we have two options for assemble. And Apollo will just choose one of them for the enactment of each function. So if we go play, you see we have much more parallelism, and then we are done, and this is the encoded string. Now, of course, in case of a real application, you probably want some more structured way of deciding where to execute your function, so you would have a better scheduler. Now, we very likely will provide some better default solutions instead of just doing it randomly. But the thing is, I also think that this scheduling will very likely be pretty application specific. So what we're going to have a look at in the next video is how you would define a scheduler of your own. But just to say that, the next video will require a little bit of a more in-depth look into how Apollo works, and you will also require some familiarity with Java. So in case you are just interested in using it, but you need some other scheduling solution, then just feel free to reach out. I think it would be pretty easy and pretty fast for us to just give you the scheduler which you need for your application. Okay, but with that, we're basically through. I hope that everything in the tutorial worked out. I hope that it was fun. If something doesn't work, or if you have some suggestions for improvement, please let me know. And I hope that you come to Userful for something. Okay, thanks a lot, and bye.